Okay, this is section 3.2, day 2 notes, example 6. So, the linear function y equals 15.95x represents the cost y. Okay, we've got to write it down. Y is the cost in dollars, the cost you pay, okay, of X tickets for a museum. So X is the number of tickets you buy. All right, each customer can buy a maximum of 4 tickets. So it says find the domain of the function. So the domain of the function is the possible X values you can put in. So you could buy no tickets. That would be 0. You could buy 1 ticket. You can't buy 1.5 tickets. It doesn't work that way. So you could buy 2 tickets, 3 tickets, and 4 tickets. And we can't go on because it said maximum of 4 tickets. So the domain is discrete because there are only very specific numbers you can buy. You can't buy numbers in between. So there's only specific numbers of tickets that you can buy. Now it wants us to graph it using its domain. So what it means by that is it's like, hey, first of all, it's discrete. So we're going to have a scatter plot full of points. We will not connect them. Second of all, we can only go from 0 to 4 because the domain restricted us to not buying more than 4 tickets. So how we find our y values is we use our equation. So y equals 15.95x. So if you plug in 0, I should have made that wider, sorry. You get 0. If you plug in 1, you get 15.95. If you plug in 2, you get 31.9. If you plug in 3, you get 47.85. And if you plug in 4, that means you bought 4 tickets, you pay $63.80. It shows up 63.8, but since we're talking dollars, we want to go out 2 decimal places. Okay, so now pitting all of this down, and I'll do my best to draw straight lines, but I will tell you I'm a lot better in person on the board than I am on this tablet. So this is our x-axis, and I need a little more space here. Let's see here. It is our number of tickets. And we want to label our axis. So now, honestly, guys, I'm going to skip every other one so it doesn't get too crowded. So this is going to be 1, 2, 3, 4. You don't have to skip every other one, but we have plenty of space, so it's kind of like, well, why not? Okay, so then this is our y-axis. All right, which once again, be patient with my lines. All right, so this is y, we're going to label it. And that was the cost, and that was in dollars. Okay, so now we need to go all the way from 0 up to $63.80. So we don't want to have the graph all scrunched down on the corner. We want to use as much of the graph paper they provided as possible. So looking at this, if I did tens, that's going to be 10, 20, 30, 40, 50, 60. That'd be right here. That just seems like I'm not making enough room. Let's go by 5s. So this would be $5. This would be $10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and 65. All right, so now because it's discrete, we just need points because we cannot connect them. So we have a point at 0, 0, a point at 1, and 15.95, that's just above 15. All right, a point at 2 and 31.90, so just above 30. 3 is 47.85, so there's 40, there's 45, so about halfway between 45 and 50. And 4 is 63.80, so go up above 60. We're closer to 65 than we are to 60. And that would be what our graph looks like. All right. So let's go look. The rest are the same as this, but I feel like we could use, probably at least one more. Let's go ahead and look at example 8. 7 is also discrete. It talks about how much money you have after buying DVDs. Well, you can't buy a partial DVD. You can only buy whole DVDs. So it's not like you can buy 1.7 DVDs. So that to me would mean that it is discrete, which it'll have a graph of a scatter plot, a graph of points. So I feel like let's skip down and do 8 because it's just a little different. So a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number G of gallons remaining is the number of M minutes. So, okay, G is the number of gallons of water, I'm going to put H2O, in the tub. M is the number of minutes that have passed. So if it's draining, it's going down. Now, usually they give you a function. Honestly, I meant to, so let's write it together. So first of all, we're starting with 20 gallons. But the bathtub is a 20-gallon bathtub, and it's full. So we have 20 gallons. Now it's draining, so that's going down. It's subtracting 2.5 gallons per minute. I guess we should call that G. So G equals 20 minus 2.5 M. That's going to be the function we use. So it is a linear function because it said it's draining 2.5 gallons per minute. That's how much it's changing each minute. So that's a constant rate of change. We're going to use that phrase a lot in algebra. So it's a constant rate of change, meaning it's going down the same amount each minute. Okay, find the domain of the function. So the domain goes with the independent variable, and the independent variable is minutes, meaning how long you let it drain. If you put the plug back in, you've changed how much water it is. So the domain is the M. So it is going to be continuous because you could drain it for no minutes, you could drain it for 1.2 minutes, you could drain it for, 3.75 minutes. So it's continuous because you can have basically a continuous amount of minutes that you let it drain. It's not just exactly 1 minute, exactly 2 minutes, and so on. So the domain, you cannot drain it at all. That's 0 minutes. Okay, so 0. 2, now it can't drain forever because eventually the water has to run out. It has to. So I'm going to make an input-output table here. So if I drained it for no minutes and I plugged 0 in for M, that'd be 20 because it's starting with 20 gallons. So now if I kept going, let's just get a few points so we can kind of get a feel for this. If I let it drain for 2 minutes, if you plug 2 in, 20 minus 2.5 times 2, that's 15 gallons left in the tub. Let's try 4. So if I plugged in 20 minus 2.5 times 4, that's 10 gallons. Let's go and try 6. All right, that's 5 gallons. And 8 is 0 gallons. I can't drain it more than 8 minutes because at 8 it's empty. So if you keep draining it, nothing's changing. There's just no water and you can't have negative gallons. So that's why the domain goes from 0 to 8. So now it wants us to graph the function using its domain. That means you can't draw the line past 8 because by that point the bathtub's empty. So our x-axis this time is M for minutes. And remember, it is only from 0 to 8. So we're going to label it number of minutes. So we'll call this 0, 1, 2, 3, 4, 5, 6, 7, 8. And personally, I don't label them all. I just do every once in a while so I can tell where I'm at pretty easily. Now the y-axis, remember we weren't using y, we were using g. So this axis we'll call g. And that is the number of gallons left in the tub, gallons of water left in the tub. So, yeah, we need to go as high as 20. So looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 17 boxes on here, so I can't go by 1. So I think I need to go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Pause if you need to make sure your graph's set up. All right, so at 0 minutes, there's 20 gallons. At 2 minutes, there's 15, 10, 12, 14. It'd be halfway between 14 and 16. All right, at 4 minutes, we're at 10 gallons. At 6 minutes, we're at 5, which would be between 4 and 6. And at 8 minutes, we're at 0. All right, and then we need to connect them because it's continuous, so that means that you need to draw your line on. And that's our graph.